We will solve the following exercise. The exercise is number 2.41. A surveyor finds that the length of the line 0A, this line, this one, 0A, is 1,500 meters, and the length of line 0B is 2,000 meters. 0B. A. Determine the components of the position vector from point A to point B. Determine the components of a unit vector that points from point A toward point B. Right? Basically, they are asking for this vector and for the corresponding unit vector. So I'm going to write down that they are asking for R, O, B. I'm sorry. My mistake. They are asking for the vector A, B. I'll check. Yeah, A, B. So this vector and the corresponding unit vector. Now they are asking for the vector RAB and the unit vector RAB as well. Now, remember guys, for when you are working with vectors, all you have to take into consideration is two things, basic two things. The first one is the magnitude and the second one is the direction. So for us to determine the vector RAB, we need either the components of the vectors OB and OA, or we can, let me put it more graphically, we need either these vectors components or we need the coordinates for the 2 points. So let me check. We have right here the angle with respect to the x-axis, right? So let me write down right here that the magnitude for this vector is equal to 1,500 meters and for the other is 2,000. Now determine the components of the position vector from point A to point B. They are asking once again for this vector and the corresponding unit vector. So this is RAB, the unit vector, and this is RAB, the vector. Let me check how we can solve this exercise. We have the angle, we have one of the magnitudes, so we can determine the coordinates, although I don't know if that's the most efficient way for us to solve this exercise, but it is one way for us to do it. So I'm going to close this shape for me to create one triangle. Let me move it right here, and I'm going to close this other shape for me to create this other triangle. Now we can determine, and I'm going to do it in dark blue, this magnitude, which I'm going to call XA. We can determine as well this other magnitude that I'm going to call YA. Orange. We can determine this other, which I'm going to call XB, and this other is equal to XY. I'm sorry, YB. I think it makes sense because I'm talking about points A and B, so every single part or component is going to be sub B in the case of B, and it's the same thing goes for A. Right, let me check if there is some other kind of way in which we can solve this exercise easily. I don't think there is. The components, we have the angle. No, and I don't want to confuse you guys, because I think that this is the most efficient way. At the end, I'm going to explain what was I thinking, because I think that it is pretty important for me to mention it, but I don't want to confuse you along the exercise, right? So as always, we're going to solve this exercise, and then I'm going to explain what was needed for me to solve it. Now, we are going to determine YB first. So YB is going to be equal to, let me check, from the top, the sine of 30 is going to be equal to the opposite cathetus, which is YB, divided by the hypotenuse, which is 2000. Right? In the case of XB, I can determine that using the cosine. So the cosine of 30 is equal to XB divided by the hypotenuse, so 2000 as well. Therefore, this is like something in Spanish. Por lo tanto. That means therefore in English. So therefore I can say that YB is equal to the sine of 30 multiplied by 2000, and the same thing goes for XB, but using the cosine of the angle, 2000. Now this is going to be equal to, you have to make sure that you are working in degrees. So sine 30 multiplied by 2000 is equal to 1000. 1000 meters, because we're working always in meters, right? Yep, everything is in meters. Now I'm going to change this to the cosine, and this is equal to 1732.0508 meters. And right here we have the components for the second magnitude, OB. I'm going to construct the vector. So the vector ROB is going to be equal to both of them positive, 1732.0508. This looks like a 6. 0508 along the I direction, plus 1000 on the J direction, and this is in meters. Alrighty, now for the second part, we're going to apply the same equations, but taking into consideration the 1500 and the different angle, basically. So the sine of 60 is equal to the opposite YA divided by the hypotenuse 1500, and the same thing goes for this part. 60 is equal to XA divided by 1500. Therefore YA is equal and XA is equal to the sine of 60 multiplied by 1500 is equal to 1299.0381. If you notice, I always use 4 significant digits after the comma. I think it is pretty accurate enough, although I know that there is a lot of things that you have to take into consideration for when you are analyzing this type of error, because this is an error. But please do not confuse about that. Now I'm going to change it to the cosine. 750, and this is in meters as well. Now the vector ROA is equal to 750 from the I direction plus 1299.0301 on the J direction, and this is in meters. Alrighty, so I'm going to do it playing with the vectors that we just did, this one and this one. So basically the vector AB is going to be equal to the final vector, this one, minus this one. All right, now, yep, I think that makes sense, and I am going to explain why in a bit. Now final, which is ROB minus initial ROA. I'm going to draw a line right here. RAB is equal to, open parentheses, 1732.0508 minus 750 on the I direction plus, open parentheses once again, 1000 minus 1299. Yep, I think. Does that make sense? Yep. 1299.0308. Once again, I do not like this number. 0308. I'm sorry, 0381. Yep, 381. Close parentheses on the J direction, and this is in meters. So 1732.0508 point minus 750 is equal to 982.0508. J direction plus 1000 minus 1299.0381. 299.081. Righty, this is equal to minus 299.0381 along the y-axis, and this is in meters. Right, so this is the first solution for the first part of the exercise. Remember, you have to make sure that you always place the unit system, and they are looking for the unit vector. So remember, guys, for when you're talking about a unit vector, you don't care anymore. Remember that I mentioned before that we are looking for direction and magnitude for when we're working with vectors. For when we're working with unit vectors, and the name suggests this, and is that the magnitude of the vector has to be equal to 1. That is like mandatory. There is a few equations for you to determine the unit vector, playing with, for example, the angle, the cosine, and the sine, although I don't remember that equation I don't have it in my mind by memory, but I know that exists, and that is important thing. And there is another one, which is the most common and used one, and this is something that I'm not going to forget, like my entire life. And this is that for in the case of the vector RAB, the unit vector RAB is going to be equal to the vector divided by the magnitude of the vector. All right, so this is equal to 982.0508 on the x-axis, the I component, minus 299.0381 on the j direction. And if you notice, we have a vector that is being divided by a scalar, right? And a scalar is simply a number, a whole number. Well, it is not necessary to be whole, but it is just a number. It doesn't have any components. It could be 1, 1.2, 3, whatever. So when you have this, you have to divide every part of the vector, every component, by the magnitude. We don't have the magnitude yet. I just realized that. For us to determine the magnitude, and I'm going to move this right here because we are going to use it later. For us to determine the magnitude of a vector, we have to use Pythagoras basically. So this is going to be the magnitude of the vector RAB is equal to the square root of 982.0508 square plus minus, open parenthesis, minus 299.03081 square. As you can see, this is pretty confusing for some students, and it was confusing for me too at the beginning when I was studying this subject. And it is that the power to the second power has to be applying to the symbol and the number. That means that this is going to be always positive, right? Because, you know, minus 299 times minus 299 is equal to a positive number, all right? So I'm going to write it down on the calculator. 982.0508 square plus, and I can get rid of that minus and that parentheses, 299.0381 square. The magnitude is equal to 1026.5707 meters. Alright, this is pretty important because this is going to be the number that is going to be dividing these other two parts. So 1026.5707, and the same thing goes for this. I'm going to save this number because I don't want to write it down every single part of the calculator. So all I have to do is to press Shift, Storage, right here, Storage, and I'm going to save it, for example, on the space A. Right? Answer has been saved within A. So for when I look for A, it is going to show me this value. Now, 982.0508 divided by A. (0.9566) along the I direction. I'm sorry, this is not a vector, this is a unit vector. Minus 299.0381 divided by, once again, A is equal to 0.2912 on the J direction. Now, there is one way in which we can know if this is correct, and it is by using Pythagoras. Remember, for a unit vector, the magnitude is going to be always 1. So 0.9566, I'm sorry, square root of 0.9566 square minus 0.2912 square. The square root 2912 9566 square. I'm sorry, I just mentioned it, and okay, as you can see, this is not equal to 1, and there is two options. The first one is that we made the process wrong, and there is an error, I don't know, at any part. I don't know, could be at the beginning, could be at the end. Maybe I draw this wrong, and this is why this is wrong as well. You have to I don't want to start over checking if this is correct, and then checking every single one of the equations that we made before. So my suggestion is like, you have to rewind a little bit the exercise, check the equation, and this is something that I mentioned before. As you can see, there is a minus there. We cannot have a minus right there. It has to be a plus, or if it's a minus, it has to be within the parentheses, remember? So I can do that, either I can do that, or I can change this to a plus. And as you can see, it is not going to be equal to 1 exactly, but it is going to be pretty accurate using the first 4 significant digits after the comma or the point. And that is why I have right here 9999, and there is a 4 right here. If I have used, for example, 5 digits, 6 digits, it is going to be closer and closer to 1, but it is accurate enough for me to know that the solution is correct. Now, What was needed for me to solve this exercise? And this is going to be a large video. First, as I mentioned before, there is some ways in which we can determine a vector. What would have happened if I, instead of doing this, I, for example, have determined the unit vector for OB and the unit vector for OA by using its angle, because I know that it is possible for us to determine the unit vector using the angle with respect of x, and then I would have to look it up, and its magnitude. I would have the unit vector and the unit vector. If the unit vectors, each one I have multiplied by the magnitude, I would have the vector. Right? There is another way, and that is something that I can do, I don't know, maybe in another video. But as you can see, with the angle and the magnitude, I would have been able to determine the unit vector, and with that unit vector by multiplication, and the unit vector has to be equal to, well, not this one, but a simple vector. All right, and every component of that vector, if I would have multiplied it by the magnitude of the vector, I would have determined the vector. All right, and with that, with those two vectors, which is this one, which is this one and this one, which are this one and this one, then I just would have to do all this and all this. There is another way for me to solve it. Now, why did I mention that the vector RAP is equal to the vector, to this vector minus this one? Right, and I'm going to draw it right here. We have the vector OB and the vector OA. So OA, OB. And we need this vector. Now, why the answer is that I have to subtract the vector A from the vector B. So ROB minus ROA. Graphically speaking, for when we have two vectors and we need the solution between those two, we have to do a closed shape, right? We have to make sure that the triangle or the shape, whatever, because it could be more than two vectors, we have to make sure that we close the shape, right? And I'm doing that by meeting the requirements of a summatory of vectors. For example, we have this vector, this other vector, and this other vector. The summatory between those three vectors is going to be equal to this. All right? Requirements. Every single one of the vector has to be touching each other tail with head. All right, as you can see, tail with head, tail with head. The solution is going to be given the other way around. Head with head, tail with tail. but the solution is given by the corner vectors. All right. Now, taking into consideration this, if I have this, if I need that the solution has to be this vector, what I can do, or well, actually it is the only solution possible, is that I'm going to change the direction of A. It is going to be pointing towards this direction. So I have OB is still positive, minus OA, because now it is going to be pointing towards the other direction, so I can meet the requirement tail with head, and the solution could be the other way around, tail with tail, head with head. All right, this is the y. Now, y, the magnitude of this vector has to be equal to this. Well, it is basically using Pythagoras, you know. For when you are looking for a magnitude of the hypotenuse, you use Pythagoras. I think that is called in English. Now, another thing that it is important for me to mention, and I was thinking it a moment ago. All right, you have to make sure and check every single part of the solutions. For example, I knew when I solved this and this that at least the symbols are correct. Why is that? Because towards this direction we have the positive numbers for y, and towards this direction we have the positive numbers for x, right? Now, this vector is the solution, and this has to be, this is important for me to mention because it is something that I was mentioning before. For this vector OB, the components are this one and this one. Remember? Tail with head, and the solution tail with tail, head with head. All right. Now, this component is positive because it is pointing towards the same direction for x positive. The same thing goes for this other component. It is positive because it is pointing towards the same direction. So I knew that this is positive and this is positive. The same thing goes for this other vector, positive and positive, because of this component and this other component giving the solution. Right? Now, the same thing goes for every single one of the vectors. This is the solution vector, right? So we have right here the solution vector. This solution vector is divided by two components, this one and this one. As you can see, the y component is pointing towards the opposite direction for y positive. That is why this component has to be negative. Alrighty. And the same thing goes for the unit vector. As you can see, the unit vector has to be pointing the same direction, and I have drawn it right here. It has to be pointing the same direction, but the magnitude changes. This is being used for us to play with the direction, but not the magnitude. Well, guys, I think that I mentioned everything. I think that it is a pretty large video, but it is pretty educating for those of you that are lost when you want to solve these exercises, these kind of exercises. And that's it, guys. This is how you can solve this exercise.